So today we're going to be doing compound probability. So up at the top we have a compound event, which is going to be basically when two or more events happen. So when I have two things happening, it'd be a compound event. The one thing that we need to make sure we understand is the difference between an independent event, which are two events that don't affect each other, and then a dependent event, which is an event that events that do affect each other. And so with these two examples, so first one I have is one of my events is choosing a marble from a bag, and then the other one is spinning a spinner. And so if I choose a marble from a bag and then I spin a spinner, it's not like choosing a marble will change what number I spin on my spinner, because they're two totally different things. So this would be an independent event. The second one, so first thing I want to do is pick a card from a deck, and then without putting it back in, I'm going to pick a second card as well. And so since these are both cards coming from the same deck, this would be a dependent event. Because if I'm trying to choose like a spade, and I draw a spade, that's going to be one less spade in the deck for when I pick my second card, kind of decreasing my chance that I'll pick another one. And so when we're doing this, the first thing that I have here, we need to make sure we understand the difference between a probability of two things happening at the same time, which would be an AND probability. And then on the back side of the notes, we'll get an OR probability, which would be two separate things happening either one at the time or both. The notation that we're going to use with this is that arc right there is going to stand for AND. So whenever I see that arc, I'm going to know that we're going to find an AND equation, which is going to be two things happening both at the same time. So I have two independent events when I'm doing these, so two separate things that are not related with one another, and I can multiply the probabilities by each other to get my total probability of the compound event. So with the first problem, we have a desk drawer contains 5 red, 6 blue, 3 black, 24 paper clips that are silver, and 16 paper clips that are white. So if we pick a random pen and paper clip, we want to find the probability that we select a blue pen and a white paper clip. So I'm going to use my AND equation. So I'm going to find the probability of drawing a blue pen, and then I can also find the probability of drawing a white paper clip. And so when I find the probability of drawing a blue pen, there's 14 total pens, so I know my bottom will be 14, and there's 6 blue pens, so I know that I'll have a 6 on the top, which reduces down to 3/7. For the white paper clip, I've got 40 total paper clips, with 16 of them being white, and that reduces down to 2/5. And so to find the probability of a blue pen and a white paper clip, what I can do is I can, again, just multiply those two probabilities by each other. So I can go 3/7 times 2/5. When I do that, I get, remember when you're multiplying fractions, multiply the tops, multiply the bottoms, and so I get 6/35. If I wanted to write it as a percentage, I could do that, and it would be 17.1%. So either of those would end up working. With the second problem that we have right below that, so rolling a standard number cube, just that's rolling a die, 6-sided die, and then spin a spinner that we have over at the right-hand side. So I want to find the probability that we roll a number less than 3. Again, AND, so I know I'm using my AND formula. And then it lands on a vowel on the spinner. So the probability of rolling a number that is less than 3, again, I've got 6 total possibilities rolling a die, and if I want it to be less than 3, I know that that would be 1 and 2, which would be 2/6 or 1/3. Then to find the probability of drawing or spinning a vowel, when I look at my spinner, U is the only vowel, so I know that there's just one chance out of 4 total options And so again, I can go ahead and find the probability of both of those happening at the same time. And so I can go probability of having a number that's less than 3 and a vowel. And so when I do that, again, I can multiply those guys together. So I can do 1/3 times 1/4, and that gives me 1/12. Again, easiest way is just multiply my tops, multiply my bottoms. And when I simplify that, that gives me 8.3%. With the last one we have here, it's what is the probability of rolling an even number with one die? And then after that, rolling a number. So I want an even number, and then rolling a 6 with another die. Again, they're independent because they're two separate dice. So again, probability of rolling an even number. So I've got 2, 4, and 6 of the even numbers on my cubes. So it's just 3/6 or 1/2. The probability then of rolling a 6, there's only one 6 out of all the numbers, so it's 1/6. And so the probability of rolling an even number and then rolling a 6, I can multiply them together, do 1/2 times 1/6, and I get, again, 1/12, which is the same thing as 8.3%. The back is where it gets a little tricky. So again, these are going to be OR equations. So underline that OR right there. And then when I look at these symbols right here, that U is going to end up being an OR equation. So if I see that U, that's talking about the OR. And so what you'll see is what I do is I take the probability of each thing happening, and then I subtract the probability that that A and B happen at the same time. And so this is actually going to be a little bit different. I'm not going to use the same formula I had on the other side because these are going to be just one event that has two different situations. So make sure for this right here, I'm not going to use the formula of multiplying the probability of A and probability of B together. I'm just going to find the possibilities where the two events happen at the same time. It's going to be kind of like finding where the overlap happens. And so for these first two problems, we're going to say that a student can only play one sport. So I want to find the probability that a student plays basketball or he's on the swim team. And so since basketball and swim team are in the same season, we know that he can't do both. So the probability that he's going to play basketball, that was 28%. And then the probability that the person swims is 24%. And then the probability that someone plays basketball and swims, again, we already said that they can only play one sport per season, and so that's going to be 0%, because you can only play one sport at a time. You can't do both. And so when I want to find the probability that someone plays basketball or he swims, I would add together the probability, so 28% plus 24%, and then subtract the 0% because there's no overlap. And so when I do that, I end up with 52%. Same thing with this second one. Talking about an athlete playing baseball and then being on the track team as well. And so again, the probability of playing baseball is 15%. Probability of running track is 23%. And then the probability of doing both, playing baseball and track, is still going to be 0 because you can only play one sport per season. And so again, the probability of playing baseball or track is I'm going to take the two probabilities, add them together, so 15% plus 23%, and then subtract off the 0%, and so I get 38%. Okay? And so these are where I'm actually going to have some overlap, so I need to make sure that I pay attention to where the overlap's happening here. So probability of rolling an even number or of rolling a multiple of 3. So the probability of rolling an even number, again, like we said, was 1 over 2. I've got 3 even numbers out of 6. And the probability of rolling a multiple of 6, or sorry, multiple of 3. And so if it's a multiple of 3, then I have to think, multiples again are going to make it more, so we're thinking of like 3, 6, 9. And so again, on a die, I'm only going to have 3 or 6 out of the 6 total options, so it'd be 2 over 6 or 1/3. And then I want to find the probability of both those happening at the same time, of an even number that is also a multiple of 3. And so the only number that is even and a multiple of 3 ends up being 6, and so there's one number that is even and multiple of 3, and then out of the 6. So when I find the probability of an even or a multiple of 3, again, I'm going to go 1/2 plus 1/3, and then subtract the 1/6. When I throw that into my calculator, remember to put parentheses around the fractions if you're in a graphing calculator. You end up with 2/3, which is 66.7%. On the bottom one, a probability of rolling an odd number or a number less than 4. Again, I'm still rolling a die, so the probability of getting an odd number is still going to be 1/2. And then the probability of a number that is less than 4, again, the numbers that are less than 4 on a die is going to be 1, 2, and 3. And on the bottom, I still have my total number of possibilities with it, which is 6. So this is another one that ends up as 3 over 6, or 1/2. Then I have the again, finding the probability of both those happening. So an odd number, and then also being a number less than 4. And so when I think of rolling a die, I can kind of look over here. I want to find the numbers that are odd and less than 4. And so I can see that 1 and 3 are going to be the odd numbers that are less than 4. And so I'll have 2 out of 6, which is 1/3. So then I can find the probability of an odd number or a number less than 4. And so again, I can do 1/2 plus 1/2, and then minus 1/3. And when I do that, I end up with 2/3, or 66.7%. And then with the last problem, cards randomly drawn from a deck of cards. Deck of cards has 52 cards. Each suit, so spades is a suit of the cards. Each suit has 13 cards, and in each suit you have one of each card, 2 through 10, Jack, Queen, King, and Ace. And so there are 4 aces in a deck of cards. And so the probability of drawing a spade, again, is going to be 13 over 52. The probability of drawing an ace is going to be 4 over 52. And then the probability of a card being a spade and an ace. There's only one card that is a spade and an ace. It's the ace of spades, and it's out of the 52 cards that we have there. So again, to find the probability that something is a spade or an ace, I can do 13 over 52 plus 4 over 52, and then minus 1 over 52. That gets me 16 over 52, which reduces down to 4 over 13. And then 30.8% chance for that happening.